Today we're going to approach a question of classic programming and AI programming. And really the question is, what do we want to do if we start getting down this project road and we find out that we've got some different user groups that need to be represented here? So what if we have to change our inference endpoint mid-project? That could happen because our company signs a different deal. Maybe we started with OpenAI and then we moved to Groq, or maybe we found out that we had two different user groups. For example, in my AI Hero course that I'm making, there's a user group that's in mainland China that needs specific access to a Chinese-based LLM. And then I've got users outside of mainland China that need access to a English-based LLM. And so is there a way that I can support both of these without having to create two courses? Fortunately, there is. So if we turn all the way back to classic design patterns, we can find this adapter pattern. The adapter pattern is this class that we put in front of our custom code that allows us to, I can record all of my lessons, for example, using this adapter class. And then when the students start it, they can just set what their inference endpoint is. This is really useful for you if you're building kind of a large AI system. You can create an adapter class just in case you need to switch out the inference endpoint in the background. For example, my original course is using Hugging Face, and that's great, but the free inference endpoint is just not cutting it for us sometimes. And so we want to be able to move to something like Groq or OpenAI and do so seamlessly. So that's the motivation behind this. And then the other piece here is, can we test it? And so one of the things that I would like to see more of in the AI world is more automated tests around AI implemented solutions. If you look at some of my other videos, I talk about how AI is really, it's not so much logic and reasoning as it is probabilistic outputs. So in classical computing, we put in an input and we get an output and it's consistent. And that's why unit tests work really well there. But we need some kind of automation that can also make sure that these are working here. So this is a very simple example of working with unit tests in this case. So with that being said, let's jump in and start doing some coding. All right, so I want to show first, this is from the course. We're actually going to make an addition to the AI Hero course, and this is the Make the Jump backend. So if you sign up for the course, you'll have all of this, but this is available for free on GitHub. You can just pop right in there. There's an env.example. You're going to want to follow the README instructions, copy that over to just .env. And then you're going to go and sign up for OpenAI and Groq API. And actually, for the purposes of this video, you can ignore those ones at the bottom. Those are for the course itself. All right, so go do that. I'll paste some links down in the bottom of the description to where you can go to sign up for those. You want to make sure your Python path is set to the dot here. And then, of course, you have Python installed. So the first thing that we're going to do is we're going to create a new class in a new Python class, and we're going to call it LLM adapter. New file. Come up here. Whoops, that didn't work. LLM adapter. So this adapter is a special kind of keyword that we get out of this really old 1995 book called Design Patterns, which you probably have heard about if you've been in the programming world for very long. And we'll start here with defining a base inference service. Okay, so this is going to be class base inference service. And we're going to put ABC, sorry, for abstraction here. And we're going to need to do an import. Oh, I keep typing ABS. So we're going to allow abstraction. And then this is going to have an abstract method, which that just means you can't actually call this base inference service, but it allows us to make sure that all the classes that inherit from it are all conforming to the same definition. We'll explain that in a bit, but the key here is that it allows us to take kind of like a least common denominator of all of the LLMs that we want to interact with and have them all output their responses in the same way so that our consuming code down the line only has to know how to interact with this base inference service, and it doesn't really have to worry about which implementation that it's using. We'll do def, and we're going to have a method called generate text. Python, you need to put a self in there because it's a class method, and all it's going to take is a prompt, which is a type string. I like typing my Python if I can. Okay, and then that's it. That's the whole thing right now to get this working. Then we're going to start with our OpenAI service. So we'll do class OpenAI service, and that one is going to inherit from the base inference service. Okay, it'll have the classic init class, and that's going to, first thing we're going to do is we're going to say self.client. So we're going to create a client, and then we're going to, this client is the one that goes to OpenAI and it goes and interacts with the API. So this is using the OpenAI SDK. So let's come down here and we'll say from OpenAI import OpenAI. Now you will need to run a pip install OpenAI. And I already have that here, but you'll need to make sure that you run that to get this working for you. Then we've got this OpenAI thing here. And if you went ahead and followed the links earlier in the description and you got an API key for OpenAI, then you can now put that in here. So we'll say we're going to grab from os.environ, and we need to also import the os method. So you can go, we'll say, where's this one? I memorized all my shortcuts, but I need to, this is the one I want right here. So if you click the light bulb here, you can also click command dot, and that'll open up the quick fixes. And so we'll say import OS. You see it popped it up here. I'll move it to the top. And then we'll say os.environ.get. And what we're going to do is we're going to get this OpenAI key that we put here. So I'm going to copy that name in here. Don't copy the key. Obviously, you don't want the key in your code. You're just getting the value that's you assigned. And this, by the way, just to make sure this is clear, you have to copy, paste this env.example and rename it as .env. You can see I have one here. Just not going to show that on the internet. Okay, does that make sense? So now you've got your init going, and that's all that's required to get this OpenAI service connected to the OpenAI API in the background. Now we have to implement this generate text method. So we're going to do that right now. So we'll say generate text, and we're going to say, well, we need a prompt, and the prompt, that'll be a string. I don't really know if I need to declare that, but we'll say model. Model's going to be a string as well, and now we're going to grab a model. We'll use a really simple ChatGPT model, partly so you don't get charged a bunch of money. We'll use the 3.5 Turbo. If you want better results, go with like the 4 series. But this will work great for now. Okay, so then we're going to go in here and we're going to say, all right, we're going to have this thing called completion, a variable called completion. And now we're going to call the client. So to call the client, you have to call self.client. Okay, and then what this client has is it has this function call on it called create, but that's inside of this area called chat. I want you to see this here. You see that you have audio, you have completions, embeddings, files, images. There's a lot of different kinds of things that you can do with the OpenAI SDK here. And so we just care about chat in this case, but let's say that you had an implementation that was using something with audio. You wanted to take a transcription or something like that, make subtitles, you could access the audio one. We're going to use chat, and then within chat, can see you don't have very much here, just completions. So we'll take completions and then we'll do a create. Okay, and they're giving me tons of maybe not super helpful suggestions how to do this here. First thing we're going to do is we're going to tell it which model we want. We're going to say model equals model. And all that's doing is we're saying, okay, we want to use the model here, which means that if you pass in a model during generate text, it'll use that one, but we're defaulting to Turbo. The next thing we want to do is messages. Okay, and so when I implement this fully in my class, in my course, I'm going to have the students declare this. For this purposes of this video, we're going to first create what's called a system message. You're probably familiar with that if you study much about prompt engineering. So this kind of sets the stage. I'm going to copy and paste this in for quickness here. It sets the stage saying, hey, this is a system message. So the user is not doing anything here. This is we're giving some tips to the model in the background, saying, hey, you're a helpful bot that gives Yogi Berra style cryptic, meaningless answers. Then we're going to say, all right, the next piece here in the messages chain, we're going to have role. Role is going to be user, okay? And you can see it's able to get this from the SDK types here. And we're going to pass in the prompt. Okay, the prompt is coming from here. All right, so this is going to create a chat completion as if you typed it into ChatGPT, basically. And then this completion will finish. Now, we could set this as streaming, we could set this as a JSON response, but what we're trying to do for the purposes of this course, the AI Hero course, is we want to just have a big chunk of text because that's easier to work with than streaming. Although obviously streaming can be really good in a chatbot site kind of scenario. So now we just need to return this. So this is where things can be a little bit different depending on the API that we're working with. So how this client is set up. So the completion one, we're going to return completion.choices. You remember how ChatGPT, if you're using it a lot of times, it'll say choice 1 or 2, which do you prefer? So that's kind of what's going on here. So we just want to say, hey, we're always taking the first one. And that's how they account for that. And then we're going to say message, and then we're going to say, hey, we just want all the content from that message. And boom, we've got ourselves a LLM adapter with an implementation right here. Okay, so that's great. We'll do Groq in a second, but let's go ahead and now create the unit tests around this. Okay, so technically they're not unit tests because they're going outside of the classes if you want to get really specific, but I'm going to call them unit tests because that's what most people are used to calling them. So we're going to make a little bit more room there. We'll start by creating a test folder here. So we'll say new folder, tests. Okay. And then we're going to, in here, we're going to create a new file and we'll call it test LLM adapter.py. All right. And then we're going to set up our unit test. So the first thing we'll do is we'll import unit test. There's a couple of different testing frameworks available in Python. I like this one, but you can go with something else if you want. And then we're going to start. So we'll do our test OpenAI implementation. This is test OpenAI implementation. And then we're going to inherit from unit test dot test case. So this is again an example of inheritance. And the first test, the way this works is it's just a method on this test class. So we're going to say test service type set. And then we'll say, we're going to pass self in there so that it has access to the class variables. And then we're going to, inside of here, we're going to say service equals, and what do we call this one over here? I'm going to go ahead and give it, all right, so we're going to, now we're getting to this place where we need to define this service. So we have this abstract class down here. And then we want to have a class that can utilize these different services, okay? So this is going to adapt them, okay? So we'll call this one, I'm going to actually put it higher up here again. Class, and we'll call this, we'll call it LLM Inference Adapter. Okay, I'm kind of making this up as I go here. And then we want to say def init, and we want to give it a service type. Okay, and then we're going to say self.service. And what we're doing in this adapter class here is we're going to choose one of these services. So before we do this piece, we're going to have to make another little function here. And we'll call this one initialize service. We're going to kind of do this as if it's a private method here. We don't want this, we want people to know not to use this for normal usage. Okay, and we're going to say, so we're going to call this initialize service, and we're going to pass it in the service type. All right, in this initialize service now, we're going to say, all right, if the service type equals OpenAI, then we're going to return an OpenAI service, which is the one down here. All right. And then we're going to give it a generate text method. Okay. And what this means is, if you'll see here, what we're doing is we're setting a self.service. This could be any of the types that we define later. Okay. So we'll say def generate text. Right. Self prompt, just like we had before. Okay, this is one that needs to conform to that. And then we're going to return self.service.generate text. And we can be sure, since these services all inherit from the, they all inherit from this base inference service, we can be sure that we're going to get what we expect here, that there is a generate text method on this. Okay, so that part is now going to be available over here. So we're going to go to this test, and we're going to run, we're going to set up the service. So what do we call this service? LLM Inference Adapter. All right, and remember, you can come over here and import it. Okay, so we're going to create a new one, and we're going to set service type, and the only kind we have right now is OpenAI. Then we're going to do this thing called self.assert is instance, and that is assert is instance is a method on this unit test, the class that this is giving us, this unit test case class. And we're going to assert it's an instance of OpenAI service. So we're going to say service.service. Remember here it says we set self.service. So we're calling this variable service. So we're saying this one service, and then the service variable inside of that. Okay, that's going to be an instance of OpenAI service. And I'm going to, I'm going to come over here and hit command dot if you're on Mac, or I think it's, I can't remember what it is for Windows, sorry. And then you add this here. Okay, and now let's go ahead and save this, and then you're going to go over here to testing. Now, if you don't have any tests set up in the this workspace, you're going to click configure Python tests, and then you'll say unit tests is the standard one, and then it's saying which directory do you want to use. So we just created a test directory, and then it says what pattern do you want to use. So I call this test underscore, so we'll do that. Right, and now it's reading out the tests, and then we're going to click play, and it passed. So it was able to check that it was indeed an OpenAI service, a type of OpenAI service. Okay, so now we've got a unit test passing. We can now add a little bit more here. So the next piece that we're going to do is we're going to give it, we're going to test this generate text method and make sure it actually works. So if you followed test-driven development, we weren't following that there because we wrote the code first, now we did the test. And we're doing that again here. We're writing the test after the code. But we're going to make a test for this here. So we're going to say test, generate text, or we could say like test text generation, is however you want it to show up here in the description. All right, and this time we're going to do the service again, and it equals LLM Inference Adapter. We'll do the service type is OpenAI again, and we're going to then go, we're going to call this one response equals service dot generate text, and we're going to say, let's do something kind of a life question, like, how do I get ahead in life? Okay, and then we're going to say self.search. In this case, what we really care about is that we're connected. Okay, we're not actually testing the goodness of the response. That would require probably using another LLM to come in and evaluate that. But in this case, we're just going to say, hey, I want to just, I'm going to cast this to a bool, say, hey, true or false was their response. And then this section here is, okay, what happened if we didn't get a response? What's the error message? We should say the response should not be empty. Okay, and then we're going to run this. Okay, we pass. All right, we're actually hitting OpenAI API here. Now let's go ahead, almost as if we were doing text generation here. If we were doing TDD, test-driven development, let's go ahead and return an empty string. So we'll comment this one out, and we'll just go return empty string, and then let's run this one again. Okay, this time it failed. All right, and we'll pull this up just slightly. Okay, because it false is not true, the response should not be empty. So it gave us exactly what we expected. All right, and then I'm going to do one more thing here. I'm going to make a test, kind of a throwaway test, but I want to see what it outputted. I'm just curious. So I'm going to say assert equal, and then I'm going to just make, so we'll say response, and then I'm going to make something up. So, and we'll run this. This will fail the test, but in the output, we'll be able to see what Yogi Berra output we got. So it said, when you come to a fork in the road, take it. Okay, so it's actually a straight Yogi Berra quote, which is not super exciting, to be honest. I was kind of hoping to do something more exciting. I might be able to tune this chat completion here with OpenAI and maybe get a better response. But we can see that it is connected, it is working, and it's following our prompts, just not super great. All right, so I'll comment that out for now. And then the last piece here that we want to show is hooking this up to Groq, because Groq is easier to sign up for. It's cheaper. You can get there's a free tier for it. With OpenAI, you kind of have to get your credit card in there right away. So if you're, I'm going to be using Groq for my class most likely, just because it's more approachable and you don't have to put in a credit card to get started. So now we're going to do some test-driven development for this. For the purpose of clarity, I'm going to make a new test class. There would be a way to do this with like table-driven tests that could allow us to write really, really clean, concise code. But I think it's easier to explain if we do it as a separate test class. So what I'm going to do is I'm going to do test Groq implementation. And we'll do unit test.test case. We're inheriting from that, so we have access to all the methods that it has. And we will I'm going to just copy in, I wrote this one separately here. We'll put this one in here. Oops, that's my bad. So this is LLM Inference Adapter. This time we're going to do Groq, and then we're going to say self.assert is instance, and we'll say service.service, just like we did, and we'll say Groq service. Now, this is part of the rules of test-driven development. So you can see that the Groq service, there is not any service that we can import here because we haven't written it. So that's considered a failing test according to the rules of test-driven development, which is totally fine. What we're going to do up here is we're going to make a new class for the Groq implementation. Okay, and we'll just put it here. And this one, we're going to go back to m.example, get your Groq API key, and put that right there. And then the other piece that we're going to need here is we're going to want to use the Groq's client. Okay, so if in your terminal, you're going to say pip install Groq. Okay, and that'll get you access to Groq. And then you're going to want to say here, Groq. Let me see if this will, yeah, so I can say from Groq, import Groq. Now I have access to it. I move it, actually that's alphabetical, that's good. All right, so now we have this Groq service we're going to create. Let me rename this here. I could have typed all this out, that might have been more clear. All right, and now we're going to make the generate text method. So with Groq, we've got a prompt. Now this generate text method has to follow the implementation that we were just using. So it has to be model, string, prompt is a string, and then we're going to use the llama 8 billion here. So I'll just make sure I get this correct here. Okay, so this is the model that Groq is aware of. And then we're going to come in here, get rid of that, and we'll say completion equals self.client.chat.completions. Now, it might be worth it to, like in Groq, we have audio, embeddings, we have a lot of the same kind of stuff. So the OpenAI defined a lot of what the rules would be around this. A lot of people are copying them. Okay, completions, create. And now inside of completions, we're going to do model equals model, just like we did. And then we're going to pass the exact same messages. Okay? Because we don't want to retype all that. All right. So there's the completion. And now we're going to check the result here at the end. I'm going to add one more thing here. You can add some more information here. So I'm going to add temperature is 1. And if you vary the temperature, you can get more creative responses and less stable responses the higher you go in temperature. It depends on the model you're using, what the temperature scale is. So like OpenAI's temperature goes 0 to 2. I'm not actually exactly sure what Groq's is going to be here using the Llama 3. But we'll go with their kind of default here. And we'll say max tokens, 124. You don't really have to put these, but these are just, we can set, hey, we don't want more output than this, okay? If that's a cost thing, or maybe it's just the size that we're going for. We don't want a size that's too big. Okay, and now we're going to return completion.choices. Again, similar here, message.content. And so then we've got a result coming out, and save that. Now if we come over here, we can import the Groq service, and now it's working, I believe. So we're just going to run all these, and we should see this new test pop up here. Okay, so the Groq one popped up. This doesn't look good. It looks like maybe it errored. let's try that again here. Okay, none is not an instance of class. Okay, what happened here? Well, our LLM adapter, okay, so we're kind of still doing a bit of TDD here. The LLM adapter, we made a Groq service so we can get it for completion, but we don't have it over here if service type equals OpenAI. You can see here, we say service type is Groq, but we don't have one for that. Okay, so we're just gonna put Groq here, and then we'll say Groq service. All right, and now I'm guessing that we'll see some past tests. All right, there we go. So now we've got test passing, and then we'll do exactly the same thing we did here. Now it's actually really easy to run these tests because we can just actually do the whole thing. We'll take this whole thing. The only thing we have to change is that we want to do Groq. We're passing it in at this. You can do this at runtime if you're instantiating the class during some type of startup process. So we're getting an LLM inference adapter that's going to be communicating with Groq. And then we're going to ask, how do I get ahead in life? And we'll do a quick run of all the tests again. Okay, and did I not save that perhaps? Let's see. Okay, so that is now passing. And then the last thing that we're going to do here is we're going to uncomment this one. It'll cause a failing test, but I want to see what kind of output we get. So now Llama is saying, it's like deja vu all over again. You'll be ahead, then you won't be. Then you'll be ahead again. Okay, that's a way better response than the ChatGPT 3.5 Turbo. So you can see you can get a really different response depending on the model. And that's it. So now in your code, you can interact with this LLM inference adapter, and you can just set which service you want. And so if you want to start adding some other services, like I'll probably be adding a mainland China service in the future. And so then for my students, I can just say, hey, in the videos, every time all the videos we're going to record, we're going to say, hey, just use the LLM inference adapter and just type in whatever service type you decided to use at the beginning of the class, and feel free to change it. And then I can record a single video. I don't ever have to get into those details in later videos, and everybody's happy and everybody's got access to what they want. So hopefully that was helpful to get some ideas how to use tests with AI, how to use some classical design patterns to be able to get access to different inference endpoints. And hopefully all that coding was fun as well. So talk to you next time. See ya.